Okay, for our second to last lesson of the year, we're just going to do a pretty basic introduction to graphing rational functions. There are two parts for graphing rational functions. We're just going to do the first part. If you take pre-cal next year, then you'll get the second part in depth. And especially if, whoever's teaching you will make sure that you get all this stuff because you didn't get the very end of it this year. So we are graphing rational functions. I think this is 8.1 or 8.2. I don't know. It's in chapter 8 somewhere. Chapter 8, we are graphing rational functions. Like I said, we're just kind of scratching the surface today. First, we need to know what a rational function is. Remember, when you have a rational number, it's a number that can be written as a fraction. Also like to think that in rational is the root word ratio, in which ratio means a fraction. So our most basic rational function, the parent function, if you will, looks like this, where the variable's in the denominator. So if you have a variable in the denominator, that's what characterizes it as a rational function. Okay, so I'm going to make a little table of values and graph this just so we can see what this graph looks like. Then we'll transform it and talk about domain and range, and that'll be it for today. So it shouldn't take too long. So I'm going to do some x's and some y's, and then we'll plot it. So I'm going to pick the numbers that we pick all the time: -2, -1, 0, 1, and 2. So now we're just going to plug the numbers in. So what is 1 divided by -2? That is -1/2. 1 divided by -1, -1. 1 divided by 0, you can't divide by 0, that does not exist. So you can say does not exist, or you can say undefined, either one's fine. 1 divided by 1 is 1, and 1 divided by 2 is 1/2. So I'll plot these 5 points, and then I'm going to have y'all think a little bit about what's going to happen the rest of the way so we can fill it in, because these 5 points, or 4 points actually, don't give us a whole lot to go off of when we're graphing this. So I'm going to fill in, or help you to fill in, some of those gaps. So we got -2, it's going to be graphed at 1/2. Oh, -1/2, sorry. Woof. So -2 is at -1/2. -1, -1. 0 is undefined, so there's not a single point that is on this line whatsoever. Okay, I'm going to hop over to 1, and its y value was 1, and then hop over to 2, whose y value was 1/2. So I plotted those points, and I really can't really tell like what's going to happen. I know I'm not going to touch this line because there's no value there at 0, but what's going on after or before -2, what's going on after 2, what's going on in between here. So let's just kind of think about it a little bit. If I plugged in -3, I would have -1/3, which is going to be smaller than -1/2. And then if I did 4, it would be 1/4, and then 1/5, and then 1/6, and then 1/7, and so on and so on. But I'm never going to get to 0 because it's always going to be 1 over some number, and that has some value. So I'm never going to get to 0 there. Same thing the other way. 3 would be 1/3. And 4 would be 1/4, and I'm getting closer and closer and closer to 0, but I'm never going to touch it. Okay, so what we have along the x-axis is what is called an asymptote. So this is going to be our horizontal asymptote. I'll spell it for you. And that is a line that is drawn that our graph is going to get really close to, but it doesn't actually meet that line in the long run, like as you go further out into the positive infinity and negative infinity in those directions. Okay, so that gives us what's going on here. And now let's fill in between the middle part. So what did we do? We said 1. What if I did 1/2? What is 1 divided by 1/2? So let's check it out. 1 divided by 1/2. Remember, when you divide a fraction, you'll flip it and multiply. So that's the same as 1 times 2 over 1, because I flipped the second one over, and that gives me 2. So if I'm going to half, I'd be at 2. And then 1/3 would be at 3. And then 1/4 would be at 4. Okay, so it's going to go up, 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 but we do know that we're not going to ever touch the y-axis because it didn't exist there. So our graph looks like that. Okay, and then we can fill it in the other way. We just go into the negative direction like that. Okay, so it looks like we have an asymptote that goes across because the graphs are getting really close to zero. They're not going to actually touch it. And then we have another asymptote that's going up and down. So we have a horizontal asymptote and a vertical asymptote. All right, so that is what your graph looks like. And when you draw these, you need to draw your asymptotes and then the two sections of your graph. Each of these are going to have two sections of the graph. Okay, so we'll talk about, we'll do domain and range real quick. So our domain, these are our x values. So our graph can be any x value except for 0, because we have an asymptote there. It can't be there. And it can be any for our range. Y is anything but 0 as well. So now we're going to do some transformations. Oh, first I'm going to have you answer a question on the question thing. So here's your own question. And the question is, describe an asymptote. So in your own words, just describe what you think an asymptote is after what I've just said. So just tell me what it is. What is an asymptote? Okay. All right. So now we're going to do our transformations. So just like any other graph we've done, we can shift these graphs up, we can shift them down, we can shift them left, we can shift them right, we can flip them over. So I'm just going to identify where the numbers are going to show up in the actual function to have us do those certain things, okay? So remember our parent function was 1 over x. So this is what's going to happen for our transformation part, okay? Our graph can be positive or negative. So the positive or negative part is normally with a number on the top. Sometimes it's sitting in the very front. All right. We can have a number that's not 1, call it A, on the top. We can have a number that's with the X. That will be our H. And we can have a number that's added at the end. So we'll go through what all these things do to the graph, and I'm pretty sure you can tell me what they are just based on what we've done before. Okay, so remember, if we have anything that's with the X or inside of our operations, that's our left and our right shift. So this is going to move to the left and to the right. The left is going to be a plus, the right's going to be a minus, just like always. A number added at the end is going to shift our graph up or down with a plus or a minus. If there's a number other than 1 that's in the numerator, that is going to be a vertical stretch or compression. It doesn't show up very much if you're just looking at the specific graphs, but if you just wanted to know what that is our vertical stretch or compression. Just makes it a little bit wider or whatever. Okay. If your graph is positive, I'll draw this over here. Oh, yikes. I'll move that. If you have a positive graph, the graph will be drawn, so I'm going to put this here, in this fashion, where the two sections of your graph that actually get sketched are in quadrants 1 and 3. So if it's positive in your numerator, if there's a plus sign in the very beginning, you'll be in quadrants 1 and 3, just based on where your asymptotes are. Okay. If it is negative, it's going to be flipped. So negative means it's flipped over. So instead of this being on the first quadrant, it's going to be in the fourth. Instead of this section being in the third, it's going to get flipped into the second quadrant. So it's 1 and 3 if it's positive, 2 and 4 if it is negative. So I'm just going to sketch a couple of these, do domain and range, show you what it is, and then we'll be good and done. So let's see. Let's just do 1 over x plus 3 minus 2. So I look at this, I don't have a plus or a minus, or I don't have a minus up there, so that's good. I don't have a flip. But it looks like I've got a number with the x, and that's going to tell me if I'm moving it to the left or to the right. So plus sign, remember, tells me I'm going to the left 3. And then this also says I'm going down 2. So I'm taking the graph that I had, I'm shifting it left 3, and I'm shifting it down 2. So that means that I'm moving my asymptotes and then sketching the graph according to that. Okay, so I'm going to go left 3, 1, 2, 3, and put an asymptote there. Okay, and then I'm going to go down 2, 1, 2, and put an asymptote there. What helps me to know like which way I'm drawing the asymptotes? My asymptotes are going to line up with the tick marks on the graph. So you see how these tick marks go this way? I'm going 3 to the left. My asymptote is going to be in that same way, like that's going up and down, so is my asymptote. This goes 2 down, my asymptote is going to go exactly on top of that tick mark. Okay, so now I know that this was positive, so I'm going to sketch in the first and third if you're thinking about the way the asymptotes go, and I'm just going to rough sketch it. We don't have to be perfect here, we're just doing transformations. So I'm going to go here and here. There we go. And then I'll write down the domain and I'll write down the range. So remember, the domains are x's. So my graph is every x value except for where the asymptote is. So the asymptote in this case is at -3. So x can be anything except for, that's a not equal to, -3. And my range, that's my y value. My y value is going to be anything except for -2. All right. So I'm going to write one on here, and what I want you to do in your question is I want you just to tell me how it shifts and then what the domain and the range are. So you might have to sketch it on your paper just to see that. So go ahead and sketch it on your paper. Yeah, that's good to do. And then tell me the domain and the range and how it shifted. But there's no way for you to like do a picture on here and show me. So here's one for you to try on your own. F of x equals 1 over x minus 4 plus 1. So right now, the question's going to pop up, but I want you to tell me how did it shift, so tell me which way it moved, and then also say the domain and the range. Okay, so do that, sketch it, do all the stuff, do that right now. Okay. And then our last thing I do want to show you for our final example, what it does look like if there's a negative in the problem, so you'll know when it needs to be flipped or whatever. So I'll put a negative with the 1 on the top. I'll go x plus, I don't know, 3. 3 is good. And then plus 4. So if I look at this problem, I know right off the bat it's going to be a negative. So when I'm thinking about the quadrants, it's not 1 and 3, it's going to be 2 and 4. So I'm going to think about that while I'm graphing it. And then plus 3 means left 3. Plus 4 is up 4. So I go left 3, 1, 2, 3. Place my asymptote. Okay. Up 4, 1, 2, 3, 4. Place my asymptote. All right, and then I just say, okay, I'm not here and here because it was a negative. It's going to be there and there, here and here, and here and here. And here I go. Sketch, and I try not to touch or cross that asymptote, but you know, sometimes things happen. So there's my graph. And then if you're asked for the domain and range, domain, x cannot be -3. And the range, y cannot be 4. So on your assignment, the first problems you just have to pick the graph. The next problems you just pick the domain, and the next problems you pick the range. But I don't ever do the domain and the range without sketching the graph because that helps me out when I'm drawing it. So don't just think I'm just going to pick a number. It does help to go through and look at what the graph looks like, even if they're not asked for that. So if you just have a little piece of paper and do a tiny bit of a sketch on there, and then that would be fine. Okay. All right, so that's all for today. Yeah, finish watching this and do your CUDA problems. Thank you very much.